Here I'll introduce you to the concept of dimensional analysis, and we will first start by trying to understand what we mean by dimension or dimensions with regard to physical quantity. So let us take a physical quantity, velocity. Now velocity is equal to distance or displacement by time. Now the unit of distance could be meter and the unit of time could be second, or it could have some other units like kilometer per second or maybe kilometer per hour. Whatever the unit, in the numerator we have some fundamental unit of length, and in the denominator we have fundamental unit of time, and therefore I can write this as L t raised to minus 1, and this is 1. So 1 is the dimension of length in velocity, and minus 1 is the dimension of time in velocity. That is what we mean by dimensions. So dimensions are basically these powers of fundamental quantities. In kinetics, we look at three fundamental units: mass, length, and time. So the power of these fundamental quantities in any physical quantity is a dimension. Let's take one more example to help us understand this better. Let's say we take the example of force. Force is mass into acceleration, and therefore this could be written as mass into distance by time square. And if I put this in the form of the fundamental units, mass as power 1, this is distance, so this will be L raised to 1, and I have t raised to the power minus 2. So we will say that the dimension of mass in force is 1, the dimension of length in force is 1, and the dimension of time in force is minus 2. So this particular physical quantity, it has dimensions of the fundamental quantities of mass, length, and time. And whatever units we may choose, these dimensions are going to remain same. For example, if I take the example of force, then the unit could is kg meter per second square. Mass is kg, distance is meter, t square is time square is second square. Or I could use probably some other unit. For example, I could use gram centimeter per second square. And we've seen that the dimension of mass is 1, it's 1 over here, meter 1, and centimeter also 1, time 2 and 2. So what we see is the units changes. From kg it becomes gram, from meter it becomes centimeter, but the dimension, these powers don't change. So that's a thing that we need to know, that the dimensions of physical quantities don't change. The units may change, but dimensions don't change. What we'll do is now is we'll look at a couple of more physical quantities and try to find out their dimensions. So let us take the example of stress. Stress is force by area. So we have already found out that the force dimension formula is mlt raised to minus 2, mlt raised to minus 2, divided by area. Area will be L square because area is length into length. So it has dimension 2 for length over here. And if I simplify this, I'll get m L raised to 1 minus 2 t raised to minus 2, and this can be written as m L raised to minus 1 t raised to minus 2. So again we can say that the dimension of mass is 1 in stress, the dimension of length is minus 1 in stress, and the dimension of time is minus 2 in stress. And this particular expression is known as the dimensional formula or dimensional equation for the physical quantity stress. So every physical quantity will have a dimensional formula, and we could go on and look at various physical quantities. For example, let us take a physical quantity, gravitational potential. Let us take gravitational potential. And even though you might not have studied this, but I can introduce this term to you and we can find out its dimensional formula. Gravitational potential is given by work done per unit mass. Work is force into distance by mass. So now I know that dimensional formula for force is mlt raised to minus 2. This is distance, so L and mass will be m. So what we will get is this m will get cancelled out. So I will have the dimensional formula as L square t raised to minus 2. Or we could also write this as m raised to the power 0, L raised to the power t, and t raised to the power minus 2. So this is the dimensional formula for gravitational potential. Now when we study mechanics, these are the three fundamental units that we talk of: mass, length, and time. But when we start studying some other concepts like magnetism, electricity, electromagnetism, there's some other basic quantities which come into play like angle, theta, current, electric current, I, amount of substance, which is mole. So we may have physical quantities which also have these as the fundamental units. But in our study, we will restrict our understanding to mechanics MLT. The other point to note is that if you have pure ratios and pure numbers, then they do not have any dimension. For example, if you take the example of pi, now pi will not have any dimension because it does not have any unit. And based on that, we have four types of physical quantities: dimensional variables, dimensional constants, and then we have dimensionless variables, and we have dimensionless constants. And I'll give examples of these four, and that will help you understand this. Dimensional. Let me begin with dimensionless constants. Dimensionless means it will not have unit and it will be a constant. So, for example, pi is a dimensionless constant because it does not have a unit and it's constant. Its value does not change. Dimensionless variable, a term which has a unit, which does not have unit but is variable. For example, theta. It does not have any dimension. It does not have any unit, but it is variable. In different cases, you will have different angles, and therefore it's an example of dimensionless variable. Dimensional constant. So a term which is constant but has dimensions. Example G, 9.8 meter per second square. So it has dimensions meters second square, and it's a constant. And all other physical quantities which have dimensions and which keep on varying fall under this category. So force, acceleration, momentum, they would all be a part of dimensional variables. So I've given you a brief introduction to dimensional analysis, and we will continue our study on dimensional analysis in the next video and look at how dimensional equations or dimensional analysis is used to check the correctness of an equation or to establish the relation among various physical quantities. Thank you.